Good evening, everyone. Welcome to today's session. This is the learning session number 3. And today we are going to cover Azure Compute Part 1. And the aim of this session today is to understand Microsoft Azure as a cloud. So welcome to this session brought to you by Kenya Data Platform User Group. And with that, we are going to start with the code of conduct of this group. And first thing first is that we all have to treat everyone with respect, kindness, and empathy. Also use welcoming and inclusive language. Be thoughtful in how you communicate, both in person and online. Avoid being destructive or inflammatory, and gracefully accept constructive criticism and listen with purpose and create space for others to communicate their preferences. Okay, moving on to the next slide. So this is slide 1 of what we are going to cover today. So these are the agendas of Azure Compute Part 1. And one of the things we're going to cover is serverless versus stateless. We're going to learn and understand what is compute, Azure Compute, and we're going to cover virtual machine topic, app service, function, and then we're going to deploy a application. Yes, let's end with the topic number 1 in our agenda items. And first 2 concepts, that is serverless and stateless. So speaking about serverless, it's not all about the absence of server, but instead it's about abstracting the infrastructure. And this enables developers to focus on code while resources are auto-scaled as needed. And on the other side, stateless means that it doesn't retain any data, and therefore it won't recall any past interaction. So this means that every request is treated as new, which ensures efficiency, but it can lack continuity since it's not keeping a record of the past interaction. So I like to think of it as a vending machine. So the purchase you make is entirely independent of the purchase of the previous and future users. So that is basically the difference between the two. Serverless, it's about the underlying infrastructure is being auto-scaled as needed, and it's not all about the absence of server. Whereas stateless, this means that past interactions are not captured. Now, let's understand what is compute. So Azure Compute refers to the hosting model for the resources that your application runs on. So we are going to focus on 3 core computing offerings that Microsoft Azure Cloud offers. So one of the compute offerings is the virtual machines. The other one is Azure App Service and Azure Functions. Number 1, virtual machines. So virtual machines, they provide on-demand, scalable, and customizable computing power. So it's like having all the power and functions of a physical server within a virtualized environment. And it provides flexibility, which means that you can easily create and delete digital versions of the physical computers. So here you might only need 1 computer or more than 1 so that you can be in a position to upscale and downscale as needed. So that is virtual machines. Another thing with virtual machines, they offer complete control over the operating system and its application. So this is ideal if you have control of the operating system or the specific software version, like a specific Python release. And with Azure, there are various operating system options, including Windows and Linux. So they provide a recognizable environment for your application, but they are customized to suit the performance of your application. So here we're going to take a look at virtual machines. So say, like, for example, take an example like a virtual machine is an application for traffic optimization in smart cities. So it requires specific software versions. So you can easily create a virtual machine to manage this and isolate it from other applications needing newer software versions. So it provides that flexibility. So number two, the compute offerings that we have provided by Microsoft Azure as a cloud is App Service. So App Service, it's a solution that supports the web application and mobile development. So this enables you to build, deploy, and scale your application and APIs based on what you really need. So with Azure App Service, it helps developers to focus on writing code and building application, while Azure takes care of the underlying infrastructure. So this is cool because you don't have like to mind about the underlying infrastructure. Do you need to upscale or to downscale? And it supports multiple languages and framework. We're going to see this in a bit. So your application built with JavaScript, Node, it supports all of those languages and their respective framework. Again, Azure App Service, it utilizes continuous integration and deployment by connecting to tools such as those hosting services like GitHub, Bitbucket, and Azure repositories. And this enables the developers to work with updates and work within different branches to manage their code easily. Another three is Azure Functions. And Azure Function, it is a serverless compute service that allows for event-driven code to be executed without the hassle of managing the infrastructure also. So here, I'd like to imagine it as an intelligent traffic light. So this will adapt and change based on certain triggers, such as the number of cars in the traffic and pedestrian needs, like crossing a junction. So similar with other functions, you can trigger code based on the changing events, such as a change in HTTP request, database changes, or even event you are specifically targeting. So this helps to auto-scale based on demand and maintain the application's responsiveness. So that is Azure Functions. And in summary, the Azure Compute offers scalable resources tailored to the demand. So it makes it cost effective with pay as you go, since it auto scales automatically, and it also upscale and downscale. So with many fully managed services, Microsoft oversees the infrastructure updates and patching. So this enables you to concentrate on the application development instead of managing the hardware itself. Yes, now let's do some hands-on demo. And here we are going to deploy an API to Azure App Service, the cloud. So if you have any question, feel free to post them in the chat. We'll have other group leads who are going to take care of that. So this is a simple API that I have, and we are going to deploy this API to Azure Cloud. That is Azure App Service. And the code base of that API is already in a repository. So we said that an app service will connect to the CI/CD, to a tool, and then enable the CI/CD actions. So this is the repository that has the code base of my API. So I want us to now get this code base, or rather the API, and deploy it to Azure Cloud. So this is Microsoft Azure Cloud. And first thing first, what I want to do, I want to create a resource group for me to group whatever that I want to do right now. So I want to create a resource group so that I would isolate what I'm doing with other projects. So I'll come here to search for resource group. So I'll create a new resource group just to isolate the API with different projects that I have. And I'll give my resource group a name, Kenya Data Platform. API. I want the region to be in East US since this is the region that is close to where I am. I won't give any tags or any value, but if you want like to really tag your resource group, you can provide the name and the value in these fields. And then I'll proceed to create my resource group. So you can see here we have a resource group created. So now I want to create an Azure App Service, which is a compute offering offered by Microsoft Azure as a cloud. So I want to host my API in Azure Cloud. So the service that I'm going to use, it's an app service. So I'll just click app service. Also, you can filter here from the search bar and then you search for app service. Then you'll get an interface similar to this one. And for this, I'll create a web app since it is an API. I'll hit on create. I'll select the subscription that I have for Azure Cloud, the Visual Studio subscription, and then I'll choose the resource group that I created initially. This is Kenya Data Platform User Group API. I'll turn this off since I don't want like to have a huge domain for my API. And then here I'm going to select the runtime stack that I created. So this I'll go with Node.js since the API is built with Node, and I'm going to select Node 20, which is the latest version. The operating system, we said we have two operating systems, Linux and Windows, and the region, I want it to be East US. East US, and here I'm going to select a plan. So this is like a pricing tier, which it's basic. So here you can choose a different pricing tier. So if the application that you are depending on the complexity, you would want to increase like the plan, and that is the vertical scaling. Where you want to increase the plan, you want to use more RAMs, more memories, more virtual CPUs. And then I don't want any redundancy since it's just a simple API for demo purposes. And then I'll proceed to the next stage. And here you'll want to enable the continuous deployment so that you're going to monitor this in the GitHub Actions. So here, definitely my GitHub account is connected to Azure Cloud. So this is the username. You can see here app of GitHub, and then I'm going to select the organization. I'll select the repository. Yeah, this is the repository that has my code base, and this is the branch. And then I'll proceed to next, networking. I'll enable public access and network injection. I won't enable that. The next step is to monitor and secure. I won't change anything at this point. Here also you can provide the tags, the name and the value of your API. So we saw the same interface while we were creating a resource group, and then we'll just proceed to creating the resource. Let me move to previous and check where the authentication issue is coming from. Okay, yeah. At this point, you'll need to enable these authentication settings so that the cloud will speak to where the code base is. Let's move on to the next networking, monitor tags, and then review and create. Still an issue. Select a different instance or create new from basics. Let me get to this step, basics. Oh yeah, here you'll need to provide the web app name of your application. Kenya Data Platform User Group API. I hope everything is okay now. Let's review and create. Yeah. So in case there are any issues, you won't be able to create anything until like you meet the required configuration steps. So as for now, here are the notifications. We are now creating the app service to host our API. The deployment is in progress. So once the deployment is succeeded, we'll move on to GitHub to monitor the workflow actions. So at that point, our code will be now be syncing back to the Azure cloud. So we are going to see the build and the deployment process. Deployment is complete. Now let's move on to GitHub action, our flows. So already our application has already passed the CI interface, that is the continuous interface, which is built. Now we are proceeding to CD, continuous deployment. That is the deployment phase. So at the build stage, that is where our code base was being prepared now to go to the deployment stage. So at build stage, we had our code being transformed to something that the deployment or the hosting cloud would handle. So at build stage, it generated an artifact. So from this stage, you can also see now the deployment phase is downloading an artifact from the build job, and then now it's logging into Azure to connect now the code base to the that we created in Azure Cloud, and then we're deploying now the API in the cloud. So it's still deploying. So the deployment stage will take long, depending how complex your application is. Yeah, so now the job is to Azure and check our API. So what I just did, I just routed to the app service itself, and then here we're going to see domain to our API. So at this point now, my code is not local; it's hosted in a cloud that is Microsoft Azure via a service that is an app service. So now we have our, and this is the default display message that the server is running on port 8080. So let's confirm a route that you'll hit so that you'll get the data. So now let's try to get this route / users and see whether we're going to the in. So I'll just append / users. Then yes, we have our data. So already our API is deployed in Azure Cloud. And that is all that I had today. So at this point, I would like to invite Kevin to take us to the next phase of this learning session. So Kevin, welcome.
Okay, thank you, Fresha, for that demo. Let me just set up something here real quick. Okay. Sorry, guys, just on 1 minute. To fix something here. Okay. Someone to confirm whether now my screen is visible and everything is okay.
Yeah, okay.
So it's visible now.
Yes.
Okay. So you can see my screen now. Okay. So let me continue. So today's call, we are talking about Azure Compute. So I'll take over the remaining part of it. So I'm going to speak about some few things. But before that, okay, my name is Kevin Chomba. I'm a Microsoft MVP and a web development and Cosmos DB. And today, as Fresha said, she took part in the Azure Compute Part 1, so I'm going to do the Part 2. So I'm going to speak about Azure Compute, specific containers, Kubernetes, and also Azure Container Instance and Azure Container apps. And then at the end of the call, we're going to deploy an API via these containers. So if you have never heard about a container, so think of these like a motorhome. So a motorhome contains everything you need, like a kitchen, bedroom, and a bathroom. But this portable and it can, it's portable and it can be driven anywhere without the worry of the compatibility with local utilities. So for this to make sense, let's say in tech now, you can think of this as a container will bundle the application and the dependencies such as libraries, uh, binaries, and configuration files into a single portable package. So due to this nature of being self-contained, they will run in a one machine without compatibility issues. So there's this meme about developers where they say, this code is running in my code base, in my machine only. So Docker came, or these containers, for example, a Docker container, came to eradicate this issue where your code is only running on your machine, but not on another person's machine. So that being said, we are going to see how you can run these containers and also how you can set up everything until we push it into an Azure container instance. So the first thing you need to understand is that Azure has various options for building and deploying containers application, such as Azure Kubernetes, commonly known as AKS. There is Azure Container Apps. Also, there is Azure Container Registry, and also there is Azure Container Instance. So Kubernetes, people like to compare Kubernetes with someone called a conductor. So a conductor is like a choir master, somewhere where there's like a bird, which is, presenting something. So Kubernetes will help you to uh, orchestrate different containers. So if you have like 4 containers, let's say you have a container which is dealing with the front end, another container is dealing with the back end, another one is dealing with the database. So you can combine those containers using Kubernetes and make sure that they are working well. So as I said, Kubernetes is a big topic. I'm not going into details. We'll have some sessions about this in future. But just to understand, Kubernetes has something we call a cluster. And then this cluster is responsible for managing different containers. And these containers, we are going to speak about them today. So Azure offers a way to host Kubernetes via Azure Kubernetes services. Okay, and Kubernetes is good in terms of scaling, especially horizontal scaling. You use Kubernetes to do that. And also, you can think of other things like monitoring. You can be able to even restart these containers as they fail. So this is a good way to understand about Azure Kubernetes service. So, but for today, we'll talk about Azure Container Instances because it's like the lightweight version of Kubernetes, but in this Azure Container Instance, it's able to just spin up one container without worrying about so many things. And then this container is lightweight. So as Fresha was taking us through Azure App Services, behind the scene, Azure App Services is just spinning up a small container. If you have ever checked the logs of when you deploy an app via Azure containers, via Azure App Service, this on the Azure portal, there's somewhere you see logs. You can already see that it is spinning up a Docker container behind the scene. So Azure Container Instance will help us to spin up or run a Docker container on Azure. And you shall see this. So there was Azure Container Apps. So this is more of like an application platform designed to simplify the deployment process and managing applications in a microservice architecture. So this is like Kubernetes, but it is more simplified. So these all services, they all rely on a container, which we shall see what it is. Okay, so let me just skip this because I've talked about it and then go to this. So Azure Container Apps, they are sometimes can be confused with Azure App Services as they both are designed to host applications, but they have some key differences here and there. For example, Azure Container Apps offer a flexible environment for containerizing applications with you can say scalability in mind, and also things like scaling up and down for the purpose of cost efficiency. So for today's demo, I'll just use the same API which Freshia was using, and we are going also to share a link to our. We don't use GitHub, but we have Azure DevOps. So it has Azure repos where you can see all the code we use, and also even other repos you can just clone and use that code we have pushed there. So for today's, we're going to concentrate on deploying an Express API. So we are going to create a Docker file, and then this Docker file will help us to create a Docker image. So this Docker image, we are going to push it to Azure Container Registry, which contains a repository for you to push as many images as you can. And then once our image, which will contain our API and all the node modules and other things, which requires the API to run, we are going to deploy one of the images which we will push to Azure Container Instance, which will help us to run our image on Azure. And then this Azure Container Instance will have something we call FQDN. You can simply think of it as a DNS, or if you don't understand a DNS, is just a word which you can search online, and it will represent an entity which is an IP address behind the scene. For example, if you say google.com, there is an IP address behind that word or that domain. So we shall have both FQDN and also an IP address which we can be able to access our API and see it. So without further ado, I'm just going to start with this, like deploying the API. So let me stop sharing this and then share my VS Code. So I hope my VS Code is visible. I think I'm going to zoom in. for the purpose of someone seeing it well. Okay. So this is my API. I'm assuming you have ever heard of JavaScript or something like that. So I'm using TypeScript, which is just like JavaScript, but with data types. So I'm just going to explain the API within 2 seconds and then we move on. So this is our server, like the main entry file, which Fresha also talked about. So it's using Express. We have one route to test, like our default route. And then we have another route to test whether we can return data. As you can see, I'm not using a database. I'm just returning an array of users. Okay, so on the other side, as you can see, the API needs a port. So we have an environmental variable to store our port. So there is somewhere we are going to use this port because a server needs a port to run. The other thing you can see, we have a Docker file, a Docker ignore, and then we have some TypeScript configurations here and there. So we are going also to build our application. So our application will run with JavaScript. So this command will be executed also. So it is going just to convert TypeScript to JavaScript. Okay. So let's talk about the Docker image, because remember on our PPT, we talked about how we are going to Dockerize our API and create an image. So the Docker file, once you create a file known as Docker file, without any extension, you just create a new file and then write the word Docker file. So once you write a Docker file, you can be able to create an image for this file. I'm assuming that you have Docker installed in your application. So I'm just going to wake my Docker application. So it's called a daemon. So if you want to do anything with Docker, you have to install it on your machine. So if you just do Docker desktop, something like that, or Docker download, um, you can be able to download Docker. So click Docker, you shall download it into your machine. Cool. So I have Docker installed in my machine. And as you can see, this is Docker. It looks like this. So there's the concept of an image and a container. So we are going to create an image and then push it to Azure Container Registry. Cool. So to do that, this is our Docker file. I'm not going to write everything. I can just explain it. So as you can see, we are getting an image from Docker Hub for Node, because remember we have to containerize our application and also install Node so that it can run on Azure. So I'm going to create a work directory inside Docker image, the image which I'm going to create. And the folder which I'm going to put my app is known as app. Okay. So, and then I'm going to copy this package.json and any word which starts with package. So it's package.json and log. I'm just going to copy them into my image. And then I'm going to install the dependencies, because package.json and log are the ones which keep track of the dependencies which are needed in my app. So, and then I'm going to copy the rest of the files into my image via this. And then when I run npm build, it's going to convert my TypeScript app into JavaScript. And then the image is going to expose a port known as 80 so that it can be accessed by the browser when we deploy our app. So when you start your image, the server will listen to this port, and then we are going to map this port to something, to another port outside, and I shall show you. And then at the end, we are going to run cmd npm start. This is going to run this command to start the server inside the image. So this being understood, then the remaining process is now creating this image. So I have these commands with me, and also this API has a README. You can just check them up. So to build um, a Docker image, it's simple. You just write. I hope the font is okay, or the size of the text. You just write Docker build, and then you add T uh, to tag your Docker image, and then you give a name. And then at the end, you use a dot to say that you're creating this image at the root of your folder. Okay. So most of us forget these dots. So don't forget these dot at the end. So what I'm going to do is to call my image simple. I'm just going to call it simple app here. So simple dash app. So that is the tag which I'm going to call it, and then press enter. So as we wait, so be patient because this process will need us to wait for some few things. I can be answering some questions. Yeah, inside the Docker file, can we use both npm and pnpm? It's not required because at the end of the day, pnpm helps you to manage your node modules in your computer. So instead of duplicating every time you install something, it checks the cache and then does that better than npm. So for Docker, you just need npm because once you install those images, those dependencies and node modules, they will sorry, they will be uh, bundled inside the image. So there's no need of using npm when you're creating. There's no need of using pnpm when you're creating your Docker image. But when you're using like your local machine, pnpm is good because you're not going to have a lot of node modules in your computer. I hope I have answered Anthony Gatito's question. Yes, remember to install Docker. So as you can see, I'm building everything. Um, so it's now converting TypeScript to JavaScript on that step, and everything is okay. And as you can see, we tagged our images simple app. So if I go to my Docker and go to images, you can see we have simple app. So my image is okay. So one step done. So we have Docker, we have tagged it. So the next thing is to, you can run the Docker image locally. Just a moment to see. Okay. I'm not sure whether I've added the .env. But okay. So the command to run Docker is docker run and then port 8080 simple app. Let's see whether it will run, and then if it won't, I'll add the env and then we shall see. Okay, so it's running by default. So the port which was stored in the NVA is working. Okay, but as you can see, it's running on a defined port. So Node have just started its port from nowhere. So the best way to do this is because there is this issue of env. So as you can see on my Docker ignore, I added .env. But if I comment this and then rebuild my image, now it will pick even the .env. This will take some few seconds because once you do something on Docker, it keeps the cache of that. So now that is done. So let's now try to run this and see. So you see now the app is running with port 80. At the first, it didn't get the .env because it was on Docker ignore. So just like the git ignore, we have Docker ignore. Cool. This is good because once you are building your app into an image, you don't want to build the image with your secrets. So you want the secrets to be added later because the image, once someone get the URL clone or copy the image, it will come with the secrets. I hope that is understood. So I'm just going to return the .env, and then I'm just going to rebuild the image now without the environmental variable, which I'm just going to do that within seconds. It will be done. And then once that is done, so now we can, we are not going to run it, but now we are going to try to push it to Azure. So there's something we call Azure CLI. So Azure CLI is a good tool to install on your local machine. So install Azure CLI for Windows. So this will help you to connect to your Azure via your command line instead of going to the Azure portal and do everything from scratch. So if you just install this Azure CLI, its short name is AZ. So once you hear me talking about AZ, it's Azure CLI on Windows. So install these in your machine. So this is the second thing we are talking about installing. So I can just share it on the chat. I think it's important for this call. So once you have that, I think we can continue. Okay, cool. So let me just clean up this terminal because it's not working well, and probably do this. So let me clean. So we have our image with us. I just need to log into Azure via AZ login. So if you do AZ login like that, you'll be able to log into your Azure account via the terminal. So this is going to open something on the browser. Okay. As you can see here, it is, which will allow you to sign in. So I have several accounts. So let me just use my MVP account and then press continue. So give it a second. It is retrieving the tenants and subscription, which are things you have to have once you have an Azure account. So as you can see, if I can zoom in a little bit, I have various ones which comes with MVP, but the one which I'm interested in is Visual Studio Enterprise. For you, you won't have a list, you'll just have one, so you just go with the default. For student ambassadors, they have these Visual Studio, so even MVPs they have. So I'm just going to select 4 for this and then press enter. And now I have access to Azure. Cool. So clear my console. So this is going to clear my console. So once I have access to Azure, I can be able now to create the Azure Container Registry. So there's a command for that, but I'm going to show you the easiest way to do this. You don't have to cram these commands. Cool. So going back to my Azure portal, let me just create a resource group. I like doing things from scratch, so that you can store your things well. So I'm just going to create a resource group, which we are going to store everything we are going to work on today. Okay, so the resource group is going to be, let me just call it demo November, something like that. You just need a unique name. East US, it doesn't matter. So I'm just going to direct to review and create because it's a resource group. Resource group is something you can use to group your Azure resources together so that they can, not Azure resources, but Azure services which you are provisioning. So going inside, I think I have to refresh for it to reflect. Yeah, so we have demo November now. Cool. So I think I can go inside here and then go to create. So I want to create something. Just a moment. Let me just drag this to this. Cool. So on Azure now we are going to create, I want to remember the name, Azure Container Registry. So this container registry is going to help us to create a repository where we can push our images. So the easiest way to do this is go to Azure Services only here. You filter the only Azure services you need, and then go to Azure Compute. So if you go to Azure Compute, you shall see everything. So for my case, I'm doing this because you can sometimes forget the name like I do. So container registry is what I want. So I'm just going to create container registry. Cool. You see it will go under our resource group. So I'm going to give it a name. So let me just say demo November. Okay, I think it's complaining because of this dash. Um, that's okay. So demo November is okay. So East US pricing is standard. That's okay. Um, for you to access these, it should be public. That's okay. Can work with that. And the keys should be managed by Azure. So I can just review and create this. So it's a simple process to create a container registry. As I said, think of it as a repository, just like the way we have Docker Hub where you can push your images. So we have Azure Container Registry where you can push your images. I think I double clicked the creation of this, but let's see what will happen. Okay, deployment in progress. So let's go to the resource now, to the container registry. So as you can see, this is the homepage of container registry, which is cool. Something to note is our name. So demo November is our name of the container registry. And I want to show you that on the repository, here it's where we shall see the image once we push it. For now, it's not there. So I just want to show you that there's no image. Cool. So if we can now we have our registry, we just need to connect our Azure Container Registry with our terminal and then push the image here. So let's see how we are going to do that. So we have commands for this. We need to log in now to our container registry. So first we logged into Azure with the easy login. So the next command is to log into its easy account login, the name of your account. So ACR is Azure Container Registry. So we are going to log into this. And I have just copied the name, if you remember. So come on. For the name is Demo November. I think that's the name. So let's see whether we shall be able to log into this. Give it a second. It should be Demo November, as you can see on the screen. So we need to log into that. Login is successful. Cool. So, and then the next thing now, I need to tag my Docker image, which I created with a tag which can be used inside my Docker, my Azure Container Registry. Okay. Today we are going to do a lot of commands, so don't worry. So the command is this Docker tag. We already did this. We already did this, but we need now to append it to something new. So which was the tag? Which tag did we use for the image? Was it simple app? Cool. Let's just edit this. So the tag which we used first was simple app. Okay, simple. I think it had a dash app. And then our account name, as I have shown you, is demo. God, it's demo November, like that, dot Azure CI input, and then your Docker image name. So this is the name which we had initially, which is the same name as the tag. You can confirm this your Docker image name in your Docker, which is just a tag we use. So I'm just going to repeat simple dash app. To just recap, we are tagging this image so that we can tag it with the name of our registry, so that the registry can accept this. So you just need to say Docker tag, the name of your image, and then the tag which is ending with the name of the image. So I'm going to press enter for this, and now the image has a new tag. I don't know whether this reflects. Yeah, it also reflects on my Docker. So this was the first image, but now I've retagged it with this. Cool. So the only remaining thing is now to push. So the command for pushing this is just docker push, and then this name we had here. So I'm just going to copy this. It's arraying the name. Okay. Okay, if you're lazy like me, you can just go back to your previous command, and then instead of tag now, you can just add push. I think this is the easiest way. Okay, so push, and then remove the name simple app. You just now retain the initial tag, demo November, simple app. So let's press this. It's going to tag with the latest tag also, and then it's going to push our Docker image. I know there's a lot of commands, but don't worry. I'll share the repo with it. It has all these instructions. You can just walk along. You don't have to cram these commands. I'm trying just to explain them. So as we wait for it, I can be showing you this demo. If you just go to this Azure DevOps, our Azure DevOps, someone asked for it. That's the repo with all the code. So you shall see this image I have drawn here and all the commands and how to do it. So you just need to clone this repo. Once you clone this repo, by this command clone, you shall get this. Just copy this. It's the same. Just do git clone and then this URL which you will copy here. And then you shall have this code. And then this is the code of the API. And then all the instructions to do whatever we are doing here. Cool. I've made it easy for you guys. Also, okay, I think it's already done. Also, if you fear using Azure DevOps, I'm just going also to share my GitHub. It has the same thing. Okay. So even on my GitHub, I have the same thing. So whichever you like, you can just use. So now we have our container. We can just confirm whether it's there. So let me just go here and then try to see. I thought I had. So let me just go to my Azure repo. I think I just closed that by mistake. So if you have a question, you can just throw it in the chat as you do this. So if I go to the resource groups and go to demo November and go to our registry and check. So in the registry, we have repositories. So if you click repositories, we should be able to see our image here, which is simple app. And if you go inside, you shall see it has a latest tag, and this is the same Docker image, which is cool. You can even pull it, so you can copy it. Okay, so the next step now from this is I'm just going to create now a container instance so that you can deploy these. Before I do that, there's something you need to enable. which you can enable with a command, or you can do it with just an option. I'm just trying to check it. Okay, so let's enable that. So going back to the container registry, there is somewhere we have, I think, access. Is it access keys? Yeah. So on the access keys, you need to enable these, okay? So that you can use these containers inside this registry. So under admin user, you need to enable these. You can do this, or you can use the command I think we have here, which is Docker account update, and then the name of your registry, and then admin enable true. So you can just write this command, or you can just remember that once you create your images, you can just come here and enable this like that. So by just clicking this is the same as writing that command. Cool. So let's continue now. I think now the remaining process is now provisioning Azure container instance. So I'm just going to my resource group as quick as possible. Don't want to make this call to be lengthy. So inside here, I'm just going to create, and then I'll be taken to the marketplace. Just going to go with Azure and then go with compute. Remember, we did this by creating the registry. Now we're going to create the container instance. So create this container instance. The name is supposed to be unique. So demo dash November app, like that. I think that's unique. Okay. And then it's going to go to this region, and I don't care about availability zone for now. But now you see, you have to check one of these. So for mine, I have already a container registry, which we did. So I'm just going to check it there. And then at the bottom, once you check this, because you gave the admin authority, Azure is going to scan through your registry and check the registries you have. So if you have 2 or 3, they will be displayed here. So I already have one, demo November, and then this registry has images, but I already have one simple. So by default, it's just going there. And this image has just one tag, which is latest. So with this, I think I'm good to go. These are the options I shared here. Select the container name, image, blah, 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 all these things. Cool. So let's go back there and then go to networking. So networking, I need to make sure that this image which I'm deploying in Azure container instance, it's public. And also it has something we call DNS name label, or what I called FQDN, this one, okay? And then it's the DNS name, if that makes sense. So I'm just going to give it like demo November DNS. I think that's available. Cool. And I'll make it public. And note, so when I was building my image, I didn't build it with a port, okay? So I ignored the .env. So if you need to add secrets to your application to an image which you did build, this is where you do that, okay? For example, these are the ports. As you can see, ports, we have 80 and TCP. So this image is going to expose port 80, not image. This container instance is going to expose port 80. I would encourage you to stick with port 80. I tried other ports, I had some issues. So I'm just going to stick with port 80. Sorry, this is not where you add .envs, but for the port. We're going next there to the .env. So monitoring, I want to monitor and check. And then on advanced now. So on advanced is where you have environmental variables. Okay, for mine, I'm just going to add port. Let me just confirm whether it is capital port or small port. Because if I don't confirm that, you can make a mistake. So port is capital P-O-T. Okay. P-O-L-T. So that's cool to know. So it's capital port, and then the value is going to be 80 as usual. So this one is going to make sure that it is going to give my image an environmental variable known as port and port 80. And then what we saw here is that this container is going to expose a port 80, which is going to be mapped to the port which is inside my image. So that's how Docker and containers work. You have outside port and then inside port. So you need to be careful about the ports. So if you have other env variables like the database connection, blah, 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 you can just add them here. So if you want your variable to be secure, that it cannot be found, you just make it secure here by saying yes. For the port, there is no need, but if you have a database URL as or other keys you need to connect your application with, you need to make sure they are yes. That being said, you can write your tag there. Then let's review and create. I know it's a little bit manual process, but this is like the easiest way to to spin up containers. So you can also create a container instance using a command. I didn't want to go there because maybe this is the first time someone is hearing about containers, so there's a lot of commands. But the good thing with Azure is that you have two options. You can use commands and also you can use the portal. Cool. So we are deploying the container instance. So remember we pushed the image. So image can only run inside a container. It's a concept even in Docker, where if you have an image, it can only run inside a container. So it's deploying now the container. Yeah, someone is saying uh, is going to revisit the whole thing again. Yeah. We are trying to make sure that in a session we have, there's like a repo, you can just go there and redo the same thing, even clone the code as far as you have access to Azure, which you can do by signing up for free. If you have a student email, you can get 100 Azure credits for this. So if that sounds good, you can do it or even on your own. So if you go to my container instance now, you shall see that my container is running and I have two options. I have an IP address and I also have a FQDN, which is like a domain. Okay. Let's first see whether our API is running. It might take like a second or two and throw maybe something there for it to kickstart because this is a DNS, but for us it's running automatic. So you can see the server is running on port 80. And then as you can see now, we also have an IP address. So if I just copy the IP address, as I said, a DNS is used to map to an IP address. So if I paste the IP address still, it will give us the same thing, if that makes sense. You see? So this IP address is the same as this domain. Something I think if you need us guys to have these sessions for these things in details, you can just say there on the chat. So we have our container instance. You can go to containers and confirm that your container demo November app is running. And if you want to see logs, you can come to logs and see whatever was being console logged is still being console logged inside our container. So this is a good way to troubleshoot and even know everything. So someone asked about our WhatsApp group. Yes, we have WhatsApp group and also Meetup and LinkedIn. So LinkedIn is where we make communications. Meetup is where we schedule our calls. You can always see the calls. And also we have our WhatsApp group. So someone can share a registration form on the chat so that you can register for everything. So this makes sense. I think now we are done with the containers. We have seen the demo. And also, as I wind up, there's something I wanted to show you guys about the same thing. So if you have already your container registry, you can deploy it directly to your container without even provisioning. So there's a shortcut I wanted to show you, but it is not giving you all the options. So once you are in your container registry where you pushed your image, if you click on the image and then go to the latest tag or whatever tag it has and go to these three buttons, you see we have run instance. Okay. So this is one way you can deploy this container. The other way is deploy to web app. So if you deploy to web app, it's going to ask you to create an app service like what Frecia asked, not asked, but demoed. She used a web app to do that. So if you need to go that route, you can just click there. The other thing is you can delete it or you can just go to run instance. So if you go to run instance, it's going to take you to somewhere where you can create a container instance, just the same way we did, but this is like a shortcut. The only issue with this way or in this road is that you have limited options. For example, as you can see, you give a name, and then there is nowhere to set up the what was the name, FNDQ, whatever, that DNS name. There's no way to set that. So you'll only have an IP address. So that's the limitation of going this route. Okay. So I would advise someone to just create a container instance, and then once you create the container instance, connect it to your container registry. So in both ways, you can try them and see. Is there anyone with a question as we wind up? Is there anyone with a question? I think I can share our registration form, but yeah, let me share our registration form. Is there anyone with a question?